This lesson is about factoring by grouping. Usually, we factor polynomials with three terms, such as the standard quadratic form ax squared plus bx plus c. But sometimes we can factor a polynomial with four terms, such as 5x cubed plus 10x squared plus 4x plus 8. This requires a totally different technique, called factoring by grouping. In order to factor such a polynomial, you must be able to group the terms into pairs, binomial pairs, with a plus sign joining them, such as the 5x cubed and the 10x squared go together, and the 4x plus 8 goes together, and you join them with a plus sign. That plus sign is very important. Then, you take out the greatest common factor, or GCF, from each pair. So in the first pair, the GCF is 5x squared. You bring it out front, leaving behind x plus 2. In the second pair, 4x plus 8, the GCF is 4, so you bring it out front, leaving behind x plus 2. Finally, if the remaining binomials are the same, i.e. they are both x plus 2, then you can treat that binomial as a greatest common factor and factor it out in front of the terms 5x squared plus 4, leaving you with a factored binomial. Ta-da! Here is an example. We have 21y cubed minus y plus 12y squared minus 4. We're going to use parentheses to make two pairs. So we group the first two terms together and the second two terms together. In each pair, you factor out the GCF from each. So in the first binomial, you can factor out a 7y, leaving behind 3y squared minus 1. And in the second binomial, you can factor out a 4, leaving behind 3y squared minus 1. That's the magic moment, when you see that each of the remaining binomials are the same. That means you've done the problem correctly and it can be factored. That common binomial comes out front to become the first binomial in your factored expression, and the leftover pieces, the 7y and the plus 4, that becomes your other binomial. Notice that the terms can be slightly rearranged and the result is still the same. If the third term is negative, make sure you keep the negative sign on the third term and place a plus sign between the two binomial pairs. For instance, example 2. We have 21y cubed plus 12y squared minus 7y minus 4. Notice that this is the same as the first problem, only I have rearranged the middle two terms to put the 12y squared as the second term and the negative 7y as the third term. I did this to point out that this third term, this negative 7y, the negative has to go with the 7 inside the parenthesis. And you have to put a plus sign in between your two pairs. This is a rule that you must follow. Once you pair up the two binomials, you go ahead and factor out the greatest common factor. From this one, we took out a 3y squared. From this one, we simply had a leading negative on the 7. The 7y and the 4 didn't share any GCF, numerical or variable, but it did have that leading negative, so you bring a negative 1 out front, changing the sign on the 7y and the 4. And sure enough, 7y plus 4, 7y plus 4, they were the same, so you bring them in front of the expression, leaving behind the other binomial to be 3y squared minus 1. You'll notice that we got the same answer as before. Here's another example of what to do if the third term is negative. Again, notice this third term is a negative 15p. That minus sign has to go with the 15 inside of the binomial. And then you simply place a plus sign in between the two binomial pairs. Again, you factor out the GCF from each binomial pair, bringing a 2p squared out of the first binomial, bringing a negative 3 out of the second binomial. You always have to bring out that leading negative. And you'll notice that the 5p plus 9 and the 5p plus 9 are the same, so you've done the problem correctly. That becomes one of your factors. And the 2p squared plus minus 3, which is really just minus 3, becomes your other factor. Here's another example, because you might have to change the order of the terms in order to even use this technique. You'll notice that the way it's written down in the first line doesn't work. It won't work. If you try it out on a sheet of paper, you'll find out that the two binomials left behind are not the same. However, by changing the order of the terms, this factoring will work by factoring by grouping. Again, notice I put the negative with the 6 inside with the negative 6 in this binomial, and I placed a plus sign in between the two. Once you are finished factoring by grouping, one or both of the resulting binomials might still be factorable using traditional methods, such as the difference of squares, or even in this previous problem, you had 8x squared minus 2. We could have brought a 2 outside of that expression, leaving behind 4x squared minus 1. In this example, example 5, we see that once we're done factoring by grouping, we have this expression x squared minus 9. This can be rewritten using the difference of squares. That's really x squared minus 3 squared. So you can rewrite it as x minus 3 times x plus 3, which is what I've done in the final answer. Finally, when using factoring by grouping, if the resulting binomials are not identical, then the terms of the polynomial either have to be rearranged or the polynomial is simply not factorable by grouping. Notice in this example, we start with 4 terms, and we group them into parentheses, and we have the plus sign in between them, and we bring out the GCF, but then, x plus 2, x minus 2, those binomials are not the same. So this expression cannot be factored by grouping. As I've explained here, the resulting binomials are not equal, so you cannot use factoring by grouping on this polynomial as it is currently written. You can try to rearrange the terms, but keep in mind that not all polynomials are factorable by grouping. Here are some practice problems for you to try out factoring by grouping. When you're done, turn to the next page and take a look at the answer key.